In this video lecture, we're going to take a quick step sideways to look at making comparisons between other types of data in Java, such as objects, strings, and floating point numbers. Okay, let's get started. When we examined the equality and relational operators a while back, we looked at them mostly in the context of making comparisons between integer numerical values. But classes can consist of various types of data bundled together. And next, we're going to need some ways of comparing different types of instance data for equality. Before we can go too much farther in that direction, we need to examine how to perform equality comparisons on the following types of data: objects in general, strings specifically, and also floating point numbers, such as doubles or floats. Whenever we're comparing any two objects in Java, be aware that there are two possible ways of doing that. The first way is through the use of the equality operator, or the double equal sign operator. The problem with this one is that it compares the values of two object references only. Or putting it in different terms, it only checks whether two object references are pointing to the same location in memory. What it does not do is check whether or not the data for two objects are identical, which is usually what we're really after. The other way of making comparisons is by using the equals method of any class, which checks whether two objects are identical field for field. And this is usually what you want to do. It turns out that all Java classes inherit a starting version of the equals method from their ultimate ancestor, the object class. Most classes will then implement their own custom version of it, just as we saw for the toString display method. As we said previously, this kind of replacement of an existing method is called overriding a method in object-oriented programming. No matter what class we are referring to, the standard interface for the equals method is always the same, and it looks like this. Equals is a public method, it returns a Boolean result to its caller, and it accepts one input, this generic object designation which can represent any object of any class. Here's another look at the interface for the equals method, along with an example of using it. If two objects are field for field equal, this method returns a true status or false otherwise. Perhaps you recall using the equals method of our CS12Date class something like this. If the month, day, and year of CS12Date object D1 are field for field equivalent to the month, day, and year of CS12Date object D2, we'd say that those two dates were indeed equal, and we return a true result to the caller, or a false otherwise. Here's a nice little example which clearly illustrates the difference between using the equal operator and equals to perform comparisons. In this code on the right, let's say we begin by instantiating two new CS12Date objects, D1 and D2, with identical dates. In memory then, this is what they'd each look like: some named object reference pointing to the actual data somewhere else in memory. Then let's say we equate date object D3 to D1, so that now we have a second object reference pointing to the same piece of memory. Finally, we'll instantiate a third date object D4, and it will look like this in memory. So next, if we perform some comparisons using the equal operator, here's what we'd get. D1 and D2 are not equal to each other because they don't point to the same region of memory, even though their date info is identical. Likewise, D1 is equal to D3 because they both point to the same region of memory. And D4, of course, isn't equal to D1 since it points to some completely different memory location. However, by using the equals method, we get a slightly different story, and perhaps one that more closely matches what we really expect. Now D1 and D2 are equal, where they weren't before. And this now makes much more sense because the date information is clearly identical. We still have D1 and D3 being equal, which makes sense because their dates are not only identical, they are the same memory. And of course, D4 isn't equal to D1 because the date information is clearly different. So comparing two objects using their equals method, as opposed to using the equality operator, is usually what we really want to do, since it compares all object data field for field, regardless of where that data lives. If you'd like to see this demonstrated in a slightly different way, please take a moment now to pause this video and view the short code walkthrough for comparing objects.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along, then come back to this video when you are finished. Well, as we know, string itself is just a specific Java class, So everything we just discussed about equality of objects in general holds equally well for strings, as well as a couple new ways of making comparisons. As we've seen, we can compare string object references using the equality operator, although usually this is not the comparison that we really want to do. If we truly want to compare the content of some strings, the string class provides its own equals method, which is really what we want to use. In fact, the string class also provides a similar equals ignore case method, so we can perform both case-sensitive and case-insensitive comparisons. We can also compare the relative lexicographical ordering of two strings by using the compare_to and compare_to_ignore case methods, which perform case-sensitive and case-insensitive comparisons, respectively. Here, lexicographical is a big fancy CS term which simply means how would two strings be ordered in a dictionary? We'd use this to perform alphabetical sorting of strings. Internally, these methods are using ASCII or Unicode numerical character codes, character by character, until the first differing value is found. We've already seen the API for the generic equals method, which allows us to compare two objects of any type. Here's an additional method the string class provides, which lets us compare two strings in a case-insensitive manner, ignoring any distinction between upper and lowercase characters. It takes a second string as its input, compares it to the current string object, and returns a Boolean result. Here's an example of how this method might be used. Let's say we have these two strings, one with an initial capital and the other without. We select the first string object as our reference, invoke the method using dot notation, and provide the second string object as our input. Because these two strings will be recognized as equal, ignoring the case, this entire expression within parentheses will evaluate to true, and this termination message will be printed. Similarly, here's the API for the string class compare_to method, which allows us to compare two strings for dictionary ordering. In both these definitions, the string object refers to the reference string, the name to the left of this method in the dot notation, and the string argument refers to the input argument within parentheses. If the reference string object comes before the string argument in dictionary order, a negative integer will be returned. Otherwise, if the reference string object comes after the string argument in dictionary order, a positive integer will be returned. But if the two strings are indeed equal, a 0 will be returned. To make these comparisons, this method relies upon the Unicode numeric character codes for each character. It checks the two strings character by character until some difference is found, and then returns a result based on that numeric character comparison. For example, here are the ASCII and Unicode values for lowercase a and b. So we'd say that a is less than b. Then here are the ASCII and Unicode values for uppercase and lowercase a. So we say that capital A is less than lowercase a. There's also a companion version compare_to_ignore case, which does the same things, except ignoring any upper-lowercase distinctions. Here's a code example which demonstrates various ways of comparing strings. Let's say that we start out with two identical strings for Hello World and another similar one, except with a W in lowercase. If we incorrectly try to perform comparisons using the equality operator, we're not comparing the strings themselves, but rather their string references, or where they each live in memory. If we compare them that way, we'll see in the output up here on the right that none of them are equal because they all occupy distinct memory locations. But if we correctly compare them using the equals method, now we'll see that string 1 and string 2 are equal, but string 1 and string 3 are not equal due to the lowercase w. However, if we repeat the same comparison using equals ignore case, now string 1 and string 3 are equal. Finally, we can also repeat the comparisons in lexicographical or dictionary order. Now we see that string 1 and string 2 are identical, so they return a 0, but string 1 is less than string 3 due to differing cases of that w. So a -32 is returned. However, if we ignore the case in the same comparison, then string 1 and string 3 are identical, so now a 0 is returned. You might be wondering where that -32 comes from. Well, the first character that differs between string 1 and string 3 is the W, and here are the Unicode values for upper and lowercase w. You might note that these character codes differ by 2 in the 16ths place, which of course is, drumroll please, 32. If you need to, please take a moment now to pause this video and view the short code walkthrough for comparing strings.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along, then come back to this video when you are finished. We'll also have the need to compare values of floating point numbers, such as floats and doubles, in our programs. And making these comparisons properly isn't as easy as it was for plain old integers. Remember that when we introduced the float and double data types, we also said that they were stored in a particular IEEE 754 format, which represented a trade-off between range and accuracy. You can go back to your earlier data lecture notes if you want to refresh your memory on this. The important point now is that any calculations involving floating point numbers can, and generally will, introduce rounding errors in the very low decimal places. It's extremely unlikely that two such floating point numbers will be bit for bit identical in all 32 or 64 bit places. For example, the simple example we'll examine will show that multiplying 10 times 0.1 is programmatically not equal to adding 0.1 to itself 10 times. Because of this, we generally don't want to compare two floating point numbers with a simple equality operator, but instead by using tolerances and threshold values. If the numerical difference between two floating point numbers is within some certain numeric threshold, we then say that those two numbers can be considered equal. This is generally the approach taken in any kind of scientific programming. We'll take a look at some examples of this in a moment. There is an alternative approach using Java's big decimal class for exact precision in calculations involving very large decimal numbers, but this is way overkill for the relatively simple problems we'll be considering in this course, so we won't cover it in this course. You can take a look at its API in java.math for more details if you're curious. Here's an example showing the proper way of comparing floating point numbers. What we're doing here is defining two double values as 0.0, then using them in two apparently identical computations and comparing the results. In this first computation, we're simply adding 0.1 in a loop 10 times. In the second computation, we're simply multiplying 0.1 times 10. Then we're comparing the results, which we'd mathematically expect to be the same, but programmatically will be different due to computational precision. In fact, here are the two output results showing this is the case. As we see in this first check, if we do a straight equality operator comparison between the two results, that result is of course false, owing to this numerical representation. But in the second check, if we take the absolute value of the difference between the results and compare that to some arbitrary numerical tolerance, which we've defined up here, then we'll see that the two results are instead equal, or rather close enough numerically for all practical purposes. In short, whenever you're comparing two floats or doubles, always do it this way, and never simply this way using the equal operator. I'll leave the details and demonstration of this for you to go through, so to finish up, please take a moment to view the short code walkthrough for comparing numbers.java, which you'll find in the usual place. And you can open up this file in JGrasp to follow along. So now that we know how to properly perform all types of common comparisons, let's next apply that to creating an equals method for our new class.